morning, class. My name is Jasmine, and I have my partner Tiara with me, and today we're going to be talking about electron configuration. The Google definition of electron configuration is the distribution of electrons of an atom or molecule in atomic or molecular orbits. So as you can see here, we have our electron configuration chart. In the first row, we have our S's. In the second row, we have our P's, third D's, and fourth F's. The S placeholder can have a maximum of 2 electrons and an orbital of 1. The P placeholder can have a maximum of 6 electrons and an orbital of 3. D can hold a maximum of 10 electrons and an orbital of 5. And F can hold a maximum of 14 electrons and orbitals of 7. I wrote this information down over here, and we actually have more letters in electron configuration. G, H, I, and K are theoretical, so they're not as precise as P, S, D, and F. So you could say you have 8 orbitals for G, but then 18 electrons, but that's all like assumptions depending on the problem that you'll be working out. To help us remember the order in which the letters follow, we have an acronym here. Sober physicists don't find giraffes hiding in kitchens. So S, P, D, F, G, H, I, K. To help remember the order of electron configuration, I listed the numbers here. It's very important to at least remember 1S through 5P, because those are the type of listings you'll most likely get at this sophomore level in chemistry. Another important thing to remember is if the atom has a positive charge, that means your electron will be taken away. For example, if the atom's atomic number was like 18, but it had a positive charge, it would change to 17, and that's what you would be listing. If it's a negative charge, the electron would be added. So with the same example, 18 would change to 19. So a quick review before Tiara leads us to our first example. This is our electron configuration chart, which follows S, P, D, and F. This is our acronym, and these are the amounts that each letter holds. Here's the order to remember. Remember, 1S to 5P would be your best bet to remember as a beginner. And then positive charge equals electrons taken away, negative equals electrons added. So Tiara is going to now lead us into our first example.
So in this periodic table, I'm going to be pulling an example from the alkali earth metals, and I'm going to be using calcium. Since we already know that calcium has 20 electrons, and we already know the order of electron configurations, now here is the electron configuration of calcium. It's going to be 1s2, since S holds 2 electrons, 2s2, 2p6, since P holds 6 electrons, 3s2, 3p6, and 4s2. If you add all these together, you should get 20, which is the amount of electrons for calcium. Now Yasmin is going to lead us into our second example on how to find the electron configuration of xenon.
So let's say thank you to Tiara for our first example, and now I'm going to lead y'all into your second example. We're going to go with Xe. So the electron configuration for Se will follow as 1s2, 2s2, 2p6, 3s2, 3d10, 4s2, 4p6, 4d10, 5s2, and 5p6. All of these will equal up to 54, and that is our electron configuration of xenon.
To find the abbreviated configuration for any element, you would need to know 3 simple steps. The first step would be to find the symbol for the element. The second step would be to write the symbol in brackets for the nearest smaller noble gas. And the third step would be to write the outer electron configuration for the remaining electrons.
So to move on to our example for abbreviated electron configuration, we're going to use zinc. Zinc has an atomic number of 30. So the full electron configuration is right here. So, to check, we have these threes will equal to 10. This will equal to 18, 20, 30. There we go. So what I underlined here is the electron configuration for argon. So knowing that, all we have to do is combine these two as our remainder. And that's how we get our abbreviated electron configuration. So to summarize what I said, to get your abbreviated electron configuration for your original element, all you have to do is take the remainder after the electron configuration for your new element. And the reason why we chose argon, because argon is in the period below. So, yes.
So I'm going to be showing you how to find the abbreviated configuration for argon on a periodic table. So first, you will need to identify the element, which will be over here. Then you will need to write the symbol in brackets for the nearest smallest noble gas, which would be neon, which is directly above it. And now I'm about to write in brackets neon. The last step will be to write the outer electron configuration for the remaining electrons. So in this case, it will be 3s2 and 3p6. So I'll write 3s2 and 3p6. And that is the abbreviated electron configuration for argon.